Well, lesson 4.3, problem 1. We're going to talk about box plots now. And I did a Zoom video just on box plots to show you what they really refer to. And in this lesson is about box plots. And so we'll get right into the lesson and show you what a box plot is and how to construct them. The first problem, based on a large national sample of working adults, U.S. Census Bureau reports the following information to travel time to work for those who do not work at home. And the lower quartile for this data sample is 9 minutes. That is the travel time to work, okay? The median of the raw data sample is 18 minutes, and the upper quartile is 33 minutes. And also given was the mean travel time, which was reported to 22.6. Now, we've talked a lot about this. Since the mean is larger than the median, we know that the distribution associated with the raw data sample is positively skewed. We know that. We've had a lot of examples in 4.2 to indicate that. So that's fairly straightforward. Now, if you remember, I went over what a box plot was, and there's 5 things that make up the box plot. The minimum value in the raw data set, okay? And it says that the minimum travel time was 1 minute, and the maximum travel time in the sample was 205 minutes. Okay? So we've got the min, we've got the lower quartile, we've got the median, we got the upper quartile, and we got the maximum. Those are the 5 things that make up the data plot, or the box plot, excuse me. Okay, now let's go down through here and see if we can pick one of these that is probably closer. I would say that this one is the closest. We're given the mean is 1 minute. That's just right off of 0 here. The lower quartile is given to be 9 minutes. So that's about here. Okay. And the median was given to be 18 minutes. Got about here. And the upper quartile, I'm sorry, right about here. And the upper quartile, it was given to be 33 minutes. It's about here. And the maximum was given to be 205, which is all the way over to here. So this is the box plot that's associated with those 5 elements that we talked about. Okay. Now, how are we going to interpret this? Were there any extreme outliers in the data set? And how can we tell? Well, an extreme outlier happens to be 3 times the interquartile distant from either end of the box plot. So if we look at, let's get out of here, and we'll go to here. Okay. And we're going to look at Q3 minus Q1. And that is what we refer to as the inner quartile range. Okay. An extreme outlier. Remember, an outlier is an data set item that is far away from the rest of the data items. Okay. And if it is greater than, okay, 3 times an inner quartile, okay, from end of box plot. It could be on the lower end, or it could be on the upper end, okay? So let's find out what this is. And if we go back to our problem, hang on just a minute, I'm sorry, I could have recorded these down. But if I share, again, I'll go back to the problem. And in the problem, what do we have here? We have the lower quartile is 9 and the upper quartile is 33. So this is equal to 33 minus 9. Okay. Which is what, 24? Right? Now, if we take 3 times the 24, let's go back. Sorry about that, jumping back and forth here, but hopefully you'll see where I'm coming from. So if we want it to be 3 times 24, okay, 64 is what it is. I'm sorry, 72. So it has to be more than 72 from end. Okay, 72. And what do we know? We know the max is 205. So 205 is greater than 72, right? And the max does not include a outlier. So I would say, because it's a large sample size, and the max is more than 3 times the inner quartile range, I would say there's most likely going to be an outlier, extreme outlier. Okay. Let's back here. And so what I would say is we selected this one. There is at least one extreme outlier at the upper end, okay, since the max is more than 3 times the inner quartile range from the nearest quartile. And that's what we come up with. And so I really believe there's probably at least one extreme outlier. Now remember, the max is selected, and it doesn't include an outlier. So if you have outliers and you're trying to find the max, it's not going to be one of these outliers, okay? So, and mild means that when you have a mild outlier in that set, it's 1.5 times the inner quartile range. So, since there's one extreme is present, we can be reasonably confident there are some mild outliers which are more than 1.5 times the inner quartile range. Okay. That's the problem.